Chemical bonding is the next chapter that we are going to do. And there are four kinds of bonding that we will deal with. But before we get into that, it is important to clarify a couple of important points. That in O levels, we used to think of bonding as we usually tell the process through which something makes a bond. So, for example, when we say ionic bonding, we say that it's a bond made by transfer of electron. And when it's a metallic bonding, it is the bond made by delocalized electrons. That's not entirely the case. Sure, that is how it is made, but that is not what it is. Whenever you talk about bonding, you have to specify कि वो है क्या. And it's really simple. In any kind of bond, there will be electrostatic force. Electrostatic force का मतलब क्या होता है? This is force of attraction between opposite charges. So that means you need something with a positive charge and something with a negative charge. Now, how exactly is that possible in this case? So let's say हमारे पास force of attraction है positive or negative अगर हम identify कर लें. Let's see, we have ionic. In ionic bonding, there is a strong electrostatic force of attraction. And the positive thing is the cation and the negative thing is the anion, and those attract each other. What they do is that they have a structure, and the structure is equally important in determining the property. So the structure of ionic substances is a structure of lattice. In fact, कहीं पे भी lattice का word आ जाएगा तो उसका मतलब है giant. So they're all in giant lattice. Then we have metallic bonding. In metallic bonding, there is a strong force of attraction. But what is the positive thing? It is the cations, which are in layers. And we have negative thing, which is the delocalized electrons. So the delocalized electrons, the free electrons, the cloud of electron, the sea of electron, वो सारे के सारे जो हैं, they are the negative part, and the cations of metals are the positive part. And the structure is basically layered. There are layers, and that is also a lattice, but it's slightly different from the giant or ionic lattice that we have here. In the ionic lattice, it's a three-dimensional structure joined by each other, everything equally joined together. But in the layers, these layers have weak attraction. Not really weak attraction, it's just that the layers can slide over each other. And we will see shortly कि वो ऐसा क्यों वो करते हैं. And then we have covalent bonding. And covalent में we have two kind of structures. There is the lattice structure. और उस lattice के अंदर भी there is a layered structure. And then we have molecular structure. So covalent में we have three kinds of structures. Now, the positive part in all of them, and this one is a little tricky, the positive part in covalent is always the two nuclei, the ones that are sharing these electrons. And the negative part is always the shared electrons. So there are pairs of electrons that they share, and those pairs of electrons are being pulled by the two nucleuses that are pulling on them. The structures will be different, of course. So how is the covalent bond different in any of these structures? It's not. It's the same throughout. But in the case of molecules, there is a new kind of force, which is van der Waals force. And we will talk about van der Waals force in detail later on. So there is the force of attraction within the molecule, which is electrostatic between the two nuclei and the shared electrons. But there will be van der Waals force in the molecules as well. And this van der Waals force is between the positive dipole and the negative dipole. So there are dipoles, and those dipoles cause these forces to be there. So as I was saying, there is going to be van der Waals forces, and those van der Waals forces are between dipoles. And these dipoles are positive and negative dipoles. And we will talk about how these are generated, or in say ये van der Waals forces कैसे बनती हैं. So in molecules, we have a new force coming out, and this is something that we used to call intermolecular force of attraction. But we will go into a little more detail कि ये है क्या. So now, what do we need to know about ionic bonding? It's really simple. You need to know that ionic bonding is the bond of attraction or the force of attraction, electrostatic attraction between oppositely charged ions. And what's the structure? It's a crystal lattice. It's the ionic lattice. Okay. Now, how are cations made? A couple of important things about cations. First of all, Cations are made by ionization energy. तो ये बात हो गई इनके बारे में. दूसरे इनके बारे में बात आपको जो पता होनी चाहिए, they are smaller than atom. So sodium atom and sodium ion, sodium atom is bigger. Now anions, they are negative charges, and the energy required to make negative charges or to give them negative charges is called electron affinity. So this energy can be positive or negative, but ionization energy is always positive all the time. This can be negative or positive, and this is electron affinity. And secondly, they are larger than their atoms. So that's another important thing to remember about the anions, and they are going to pull on them. You should be able to draw the dot and cross diagram for that. And I don't think that will be very tough. A couple of important things to remember is that, for example, I take, let's say, calcium chloride. Now in calcium chloride, I have the calcium atom with the last 2 electrons. So I can draw that. And I can use either circle, or I can use a filled circle, or I can use a cross. So these 3 symbols are acceptable, and I can use any of these. Now, this is calcium atom. I've only drawn the last shell because that's the only thing that takes part in the reaction. But when it loses electron, these electrons are gone, and I can draw the empty shell if I want, with square brackets to show it's a charged particle. If I don't like that, I can still draw the shell that is inside. Obviously, the 4th shell is gone, the 3rd shell is still there. I can draw that if I want, but an empty shell is also acceptable. At the same time, when it comes to chloride, I will obviously have 7 electrons of its own. So I should use a different symbol. I could use a colored dot, or I could use a cross. So let's say I use a cross. It's customary to put them in pairs, because they exist in orbitals as pairs. So this is kind of also telling me that there are 4 orbitals that are filled up. And the one that just came, I will use a different symbol for that. Again, it's a good idea to do that, but you won't lose marks if you don't. If you use crosses for all of them, that's also fine. But a good chemistry student would use different symbols to signify that there's a different source of these electrons. The negative charge should be written like that. And even though this is 2, we will not write 2 here. Why is that? Because this is not the actual number. This is empirical formula. In fact, in all the lattice structures, wherever you see them, covalent, metallic, ionic, all the lattice structures will only show the empirical formula. Now, I would suggest, just to make sure that you know what this is all, you answer 3 questions for yourself. What is ionic bonding? Define it. Mention or explain how magnesium reacts with chlorine. And lastly, draw the configuration or the dot and cross diagram for magnesium fluoride. I would suggest that you do it and try to get your answer. Another important thing to remember over here would be that we might be asked to calculate the electrons involved, or to figure out what the charges are on a certain ion. So one such example is sodium azide. Sodium azide is this compound. Now, we know that sodium has a positive 1 charge. And to cancel it out, obviously azide must have a negative charge. But this also means that since this is sodium ion, the rest of it is actually the azide ion. So that clearly shows us that this is the azide ion. And that's interesting because this is a molecular ion. That's another term that I just said. Molecular ion. These are ions that are made through covalent bonding, but they have charges on them. So that makes them molecules, but at the same time, they are ions. We are familiar with them. We know sulfate, carbonate, nitrate, hydroxide, ammonium. They're all molecular ions, polyatomic ions. And we will see many more like cyanate or amines and all that. And we will keep on looking at those. These ions are also called something else if you are in organic chemistry. In organic chemistry, the cations and anions are there, but they don't exist as ionic lattice. They are just species that are taking part in reactions. So in organic chemistry, I mean, organic chemistry may, we call the positively charged species, we call them electrophile. And the negatively charged species is called nucleophile. But the important thing to remember is that they do not exist as ionic lattice, which makes them different from the ionic compounds. Because electrophiles and nucleophiles, even though they share the idea that one is having a positive charge just like cation, and one is having a negative charge just like anion, at the same time, because they don't form a lattice, they're not forming ionic bonds with each other. So electrophile has a positive charge and nucleophile has a negative charge. Clear? All right. Now, what about ionic compounds? Ionic compounds, they have strong force of attraction. There's an infinite assembly or lattice of these ions, which means that there's going to be strong attraction. And if you disturb it, all the lattice will be disturbed. So that means they're going to be having high melting points. The forces are really strong, so they're non-volatile. And you need to break the whole lattice to melt them. So that's the first idea, that they have high melting and boiling point, and they have high density at the same time. Similarly, they are bad conductors because they don't have any free ions. Even though ions are there, they don't have free ions. And they are relatively soluble, not all of them, but they're relatively soluble in polar substances or polar solvents. Water is a polar solvent, and we'll talk about what polarity means. Okay, so those are usually the three main ideas that are associated with them. Then they are excellent electrolytes, which means that if you melt them or you dissolve them in water, their solutions, they will conduct electricity. And again, that is because of availability of electrons, something that we've seen earlier on as well. So this is nothing new for us. हमने O levels में सारा देखा, but there is one point that I want to ensure कि आपको अभी समझ आ जाए. These are brittle. They are hard. Why is that? Why do they break so easily? Even though they have strong force of attraction, why do they break so easily? So उसके लिए we have to understand how the structure is going to be. So I'm going to draw negative and positive ions here. Let's say this is positive, so this will be negative, this will be positive, this will be negative. Similarly, this is negative, so this will be positive, this will be negative, this will be positive. Now imagine, so this is how the structure is usually like. There is strong force of attraction between oppositely charged ions, and they surround each other like that. But what will happen if I apply some force on this layer at the top? Let's say मैं यहाँ से इसको push करता हूँ. And if I succeed in pushing it, this will maybe nudge to one side. Now over here, they have strong force of attraction between positive and negative, positive, negative, positive, negative. Strong force of attraction. But the moment I push this to a side, there is strong repulsion. Really, really strong repulsion. And because of that, the whole layer falls off. So you get a very clean cut, which is why their surfaces, they have very sharp boundary. Because अगर एक lattice उतरती है तो सारी ही उतर जाती है. So that is why these are hard, because there is a strong repulsion if there's even a slight change in the placement of these ions and they come close to each other with the same charges. So for example, there are many uses of these as well. So for example, magnesium oxide is used for lining electric furnaces. क्यों? Because it does not conduct, and at the same time, it can withstand very high temperatures. So all of that is coming together. And that is what ionic compounds are like. metallic substances are different from them. In metallic bonding, you don't have negative ions. You still have lattice, just like these. And I would like to just copy this one over here. So you still have the lattice, but the lattice is different. Instead of having positive and negative charges, you have positive, 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 positive. All of them are positive. And how is it possible that positive charges एक दूसरे के साथ रहें? Because they're surrounded by negative electrons all around them. And these negative electrons are making a cloud of electrons. So this is a sea of delocalized electrons that is all around them. So her positive charge is being pulled by this strong mobile electrons or very strong force of attraction. So we use the word sea, we use the word cloud, we use the word mobile electrons, we use the word delocalized electron. The idea is that they are kind of like they've offloaded these electrons in the last shell. So obviously the electrons that are coming from atoms with more valence electrons, they will have stronger metallic bonding. So atoms with more valence electrons have stronger metallic bonding. And why is that? It's really simple. That is because they have more electrons to attract. And obviously the charge density on the cations is also higher. So the strength of the metallic bond increases with the number of electrons that are donated, that are lost, that are offloaded by the ions in the middle. उससे क्या होता है कि if I push this layer, the cloud is also broken down with it. So overall, कोई फर्क नहीं पड़ता है. The bonding is still there. The bonding is still made again. कोई टूट नहीं रही हैं वो bonds. So that is possible कि हमें इस पूरे portion को move करवा दो. But वो नई bonds बन जाएंगी. कोई इतना ज़्यादा problem नहीं है. So that makes them ductile. That makes them malleable because the bond is easily remade. And of course, they have all the properties that we know about from O levels. There is one thing which I would like to talk about, which we haven't seen in O levels. That is, what if you have solid covalent substances? उनमें कौन सी lattice होती है? Imagine if I freezed chlorine or oxygen. Frozen oxygen में कौन सी bonding होती है? उनके भी तो crystals होते हैं. होता ये कि frozen oxygen में you have this molecule, and that molecule is surrounded by another molecule, which is surrounded by another molecule. Okay? And they are all there, haphazardly arranged, all of that, of course. But because of the electrons that they have, उनके ऊपर slight positive और slight negative charges आ जाते हैं. So एक के electrons दूसरे के electrons को push करते हैं, and we get slight charges like this. Kind of like what we have already seen in cations and anions, but they're not that strongly there and the electrons are moving around rapidly. So these are called instantaneous dipoles. And these instantaneous dipoles are also called going to form force of attraction because positive और negative तो है, चाहे वो थोड़ा है, weak है, चाहे वो charge इतना strong नहीं है, चाहे वो charge आगे दूर जाएंगे तो ठीक खत्म हो जाएगा, neutralize हो जाएगा, but at the time तो वो है ना. So this gives us what we call London dispersion force, which we also called van der Waals force. And this is weak, easily broken, but it is there when they are solidified or they're frozen. So this is molecular lattice. So that was molecular lattice. Of course, हमारे पास जो giant structures हैं, जैसे diamond है, graphite है, I don't think there's anything extra that is in A levels that wasn't there in O levels. In graphite, diamond, there's nothing new.
Yeah, no, that's fine.
Yeah, वो O levels वाली ही बातें हैं. There is one small idea that we need to remember, that there are allotropes of carbon. And allotropes क्या होते हैं? Allotropes are same element, same state, but different structure. That's what allotropes are. And because of this, you have many versatile structures that come out of carbon. So carbon के बहुत से allotropes होते हैं. Of course, oxygen के भी हमारे पास O2 and O3 एक allotropes हैं. Sulfur के बहुत से allotropes होते हैं. Silicon के allotropes होते हैं. But carbon is primarily the one that we study because it's very versatile. So carbon की कुछ allotropes हमने पहले से देखे हुए हैं. जैसे we know about diamond, we know about graphite, but there's also fullerene. Fullerenes are molecular carbon, और वो फुटबॉल की तरह का मॉलिक्यूल होता है. They sublime, which means that they show sublimation. They don't melt. They go directly from solid to gas. They are poor conductors of electricity because उनमें इलेक्ट्रॉन्स जो है ना वो बहुत ज्यादा डीलोकलाइज नहीं हुए होते हैं जैसे ग्राफाइट में इलेक्ट्रॉन्स डीलोकलाइज होते हैं, बट इनमें बहुत ज्यादा नहीं होता. एंड fullerene is actually more reactive than graphite. Of course, diamond तो बिल्कुल ही reactive नहीं है ना, क्योंकि bonds are there's a multitude of bonds and they're really strong, so उन सबको तोड़ना पड़ता है. But fullerenes, because they're molecular, they're easily reactive, and they react with a whole lot of molecules and substances like bromine or oxygen or hydrogen, all that. Then we also have graphene. And we have CNTs. CNT is carbon nanotube. It is basically graphene, या आप समझ लो ग्राफाइट है लेकिन उसको हमने बेंड करके उसका एक सिलेंडर सा बना लिया. So that is carbon nanotube. They are extremely strong, very high melting point stuff, and they are very good electrical conductors. Problem क्या है कि वो बहुत छोटे साइज की होती हैं. So उस वजह से we haven't been able to make really large scale nanotubes. So उसकी वजह से क्या है कि we use them in small batteries, we use them in as electrodes, we use them in tiny circuits like body के अंदर कोई robot भेजना है drug delivery के लिए तो उसके circuitry में use होता है. या we use them whenever we want to like make really strong clothes और जैसे protective suits होते हैं उनको बनाने के लिए we can use them. So but large scale use इनका अभी तक हमें we haven't gotten the technology to do that. Graphene is basically just a single layer of graphite. You take the layer at the top, that is a graphene layer. And this is pretty reactive, low melting point stuff, but extremely strong. And because उसमें just like graphite, उसी से वो बनी होती है, तो उसमें भी free electrons होते हैं. So it conducts electricity. Okay. So in your answers, in any question in the exam paper, make sure कि आप जो भी substance की बात कर रहे हैं, अगर उसने question bonding का ही पूछा हुआ है, it will always help अगर हम structure का भी उसमें जिक्र कर दें, because there's nothing terribly wrong with doing that.